So let's go. So this is one of those infamous questions. What is actually smart manufacturing? And I think we probably should have put smart in parentheses because there's about 50 different definitions of what smart actually means. And I'm sure a lot of you who are on this webinar have had their versions of Industry 4.0 in industrial Internet, Internet of Things, take a pick of different terminology, but in essence, our view of smart manufacturing is what makes your life easier and what makes you more informed so that you can react much more proactively. I kind of personally subscribe to the General Electric's vision of this, which is zero unplanned downtime being the most operating word in the smart manufacturing. So the idea being here that you cannot avoid some sort of downtime as you try to produce things, but how can you minimize the effect of that particular event on what you're trying to do? But instead of just going and reading a lot of things and trying to figure out, what we have changed in our company in the last few years is we're actually going out into the field and doing research. So we're coming to you, customers, and not only asking questions, but observing exactly what you do. Primary thing here being is that you don't necessarily use the equipment as we intended it to be. And unless we go see exactly what you do, we have no idea what you're trying to do. So we have done 2 research studies, and our more recent one was a very big one, which we took over 8 months to complete. So we visited 35 sites, 12 in the US, and the rest were in Europe. We observed 138 different machines. Some were in a metrology lab, some were in a pop-up lab, some were on a shop floor. And we interviewed 94 people. And an interesting thing about those interviews is that initially the reaction is, oh, people don't want to talk to you. But when we actually go to the sites, we have to extract ourselves from interviews because people like to share a lot of stuff because they're very excited to tell us how they actually either are trying to be smart or already are smart, because there's plenty of companies out there that are doing some of this work that we are trying to move the whole industry into. In total, we observed 150 hours of operation, which means we took photos, we filmed, we observed what people do left and right and how they actually do things on the shop floor. And in a breakdown of the actual industries, we looked at automotive for the most part, powertrain, aerospace, medical, and then miscellaneous are typically what we call job shops, so any kind of facility that does multiple different industries and multiple segments. And of course, from the software standpoint, it was mostly using Hexagon software, which is PC-DEMOS. There were some Windows users, and there were some users of competitive software that we also observed. The interesting thing is we did a much smaller version of this about 4 years ago, and to kind of give you a little bit of brief of how does innovation actually happen is that when we did the initial observation, we talked to a bunch of people, we asked them what they would like to see. And it turns out that in metrology, nobody's asking for more accurate machines and faster machines. Well, faster is an argument. What exactly does faster mean? But the main thing that came out of the initial research was that people wanted us to put lights on the machines, which is the surprising answer that you run into sometimes when you go into the field, because you certainly expect a different question to arise. So the main reason why I'm covering this is to say that we, in order to really realize what stuff is, we have to understand the process and what people actually do in order to be able to provide the right solution. So out of these things, the first insight came with some common operational questions, which is, ultimately, do you run your CMM unattended? So do you actually leave the room and leave your machines running, or they're part of the production line and they're not attended, there is a robot next to it? And if one of those machines actually goes down, what is the effect of the actual downtime? So if you leave and something happens and you come back, how much do you affect the downstream and upstream if one of those machines is down? And in fact, how do you ensure that a CMM is measuring your parts in acceptable environmental conditions like temperature and humidity? How do you know if there was a crash? How do you handle if there was a probe crash? And how do you know if there was any actual vibration? And all those questions lead us into how do you make your metrology operation smarter, meaning how do you not only get the feedback of measurement, but how do you know that everything that you measured was done in a correct environment? And those were the initial questions that kind of led us into just addressing some basic issues that you run into. And I'll give you a couple of examples that come across our mind doing this. One was you have a 3-hour routine that you have to run your CMM. You start it, you leave, there's some dirt in one of the bores, machine goes in to try to measure it and just stops. And then you come back 3 hours later, and machine is stuck on feature number 1 and just still measuring that thing and hasn't moved. Of course, you will have some chosen words for the machine, and then you'll reset, and you clean it up, and then you'll continue on. The other one is if you have vibration issues, and we had one of our customers who had a train tracks next to their machine, and the train line changed the schedule, never told the company, and they had mysterious things happening on the 3rd shift until they eventually discovered that a train changed their timetable. If you had some way of doing all this, you would be much more effective because you could drill down to the actual problem much more efficiently, much more quickly. So the insight number 2 is a result of those questions. So today, not to beat up on ourselves, but we are a reactive enterprise. And what does a reactive enterprise actually mean? That means that if something happens to you and it happens in your machine, you react to it, meaning machine is broken, machine is down, there's something else happening, and that's regardless of whether it's a CMM or anything else. You typically call service, service says I can be there tomorrow, service shows up. They might have or might not have all the parts. If they have to order a part, it's another day that you have to wait for the part to show up, and eventually they fix, everybody's happy and everybody goes home. But in those kind of situations, if the reaction is not swift enough, if the part is missing or something else, you risk potentially being down for 1 day, 2 days, or whatever, or just a couple of hours. It doesn't really matter. If we're able to sensor these machines and connect them to our back office, then essentially we can start becoming proactive, meaning that if we know together with you that something has happened on the machine, we can be much more proactive in how we react to those events and problems. If we ultimately are able to connect many, many, many machines and collect a lot of data, which is this bottom line that goes from thousands of points of data to billions of points of data, we can start predicting behavior of our machines. That means, in a typical example, a drive system on a global machine is a belt system, which means belts over time get loose, and you have to retighten and reset the belts. If we knew an exact moment where that happens so that we can dispatch a service person so you don't have to wait until you notice a problem and then we come and fix it, those are the typical examples of predictive maintenance kind of issues. And if you look at the initial 2 slides and 2 insights, they're all pushing toward the idea of zero unplanned downtime and the idea that ultimately you want to be prepared when something happens in the machine, and you also want to be aware if something has actually happened, because ultimately that affects the quality of the data you're gathering on those pieces of equipment. The insight number 3 is that regardless of what we say, and I can use that picture on the right where there's a bunch of robots doing some stuff on the car body, and then all of you guys have some version of those kinds of things running, all this machinery generates data. Typically, less than 1% of that data is actually used for anything. So we generate a lot of data as a humanity. Everybody can think of Snapchats and Facebooks and Twitters, but really most of that data is just garbage, and we don't mine it, we don't look at it, we don't actually do anything with it, which means that interaction for most part is not personal, it's not at the right time, and it's not relevant. And what does it exactly mean? Well, it's not personal because if I don't know what's going on with your machines, then I kind of have to guess or ask you 10 million questions, which means you are no different than any other customer. I just don't know much about what exactly do you do. It's not at the right time, which we pretty much covered what it exactly means, because the right time is yesterday, as we all know. So being present and being able to fix things ahead of time means we will be at the right time. And relevance just goes back into the not at the right time piece, which is the relevance of what we try to do was relevant yesterday. It's not relevant today. So if we're able, excuse me, to actually be able to harvest and use more of that data, ultimately we will be able to offer you a much more personal, much more precise, and much more relevant services in the future. So Dirk asked a good question. He said, well, give us one of the examples in a typical world what other companies are doing, and we'll pick one of the small companies like GE, that if anybody has seen more recent ads on TV, is trying to kind of to make fun of themselves and present themselves as to who they are, which is they're shifting more and more of their things to actual software and getting away from a lot of hardware development, which they used to do in the past. So if you look at the left piece, it's kind of how do they view what exactly industrial internet or Industry 4.0 requirements are. And if we go from left to right, cloud is the big piece because it allows you to access the data from any place and any time. Mobile is how we all essentially communicate. All of you guys have either an iPhone or an Android, and a few unlucky souls might have a BlackBerry or Windows phone. And you use those devices to actually access internal, external networks, messaging people, trying to get your enterprise to be as proactive as possible. Obviously, security is a big piece of this pie, and we have to make sure the data is secure. Part of my title is obviously user experience, so having a consistent and meaningful user experience is very important because ultimately we're taking a lot of complex data and trying to bottle it and give it to you so that you can consume exactly what does the data actually mean and how does it affect your enterprise. In long term, as you supplement all this data, you transition to what they are referring to as brilliant machines. And brilliant machines are ultimately machines that are able to learn and have some sort of rudimentary artificial intelligence to make certain decisions. So rather than you having been relied on to make every decision, machine can actually either ask for permission to do something or actually be allowed to make a certain decision that affects a process. Ultimately, if you have the cloud, then you can also manage your assets, meaning in our world, if you have 5 CMMs sitting next to each other, an interesting study we did during our research is we had a company that had 5 CMMs in a room, and the CMM that was closest to the door was overutilized, and the CMM that was furthest from the door was underutilized, and they were all exactly the same CMMs, which is essentially the idea that people don't like to walk too far, so they would usually just use the CMM that was closest. But if you had some sort of asset management to tell you about utilization of these machines, you could start adjusting that and suggesting to people where to put the particular part for inspection. And finally, the piece that we covered a little bit earlier is that once you have all this data, is where you can start getting predictive and you're getting insight from that big data to affect your operation. And it's not only limited to metrology, obviously this is expanded to everything that you manufacture and how you manufacture. So if you take the left piece, it's really talking about modern manufacturing enterprise and what are the requirements to move it into the industrial internet of the future. If we switch to the right side, there's another example from General Electric, which is talk about benefits in digital worlds. So if you look at on the bottom piece, when you start with an aircraft engine and then an aircraft and then a fleet of airplanes and then a network of where the planes are actually flying, what you're slowly moving is from optimizing the asset, which is the engine, optimizing, they call it a facility, which is essentially the plane, then optimizing the fleet, and then finally having the network optimization. And what it allows us to do is move from intelligent devices to intelligent systems to an intelligent decisioning of what we're trying to do. So the bottom line here is that as we start connecting things, as we start having access to data, as we're able to put in some decision-making ability into the machines we work with, ultimately makes us much more productive and more efficient. And in our industrial world, GE is one of at the forefront on some of these kind of issues, and you can yourself, they're using something called Predix platform, if you need some additional research to look at this stuff, just feel free to go to their website, and they have a lot of good white papers kind of describing their vision of what manufacturing should be like in the future. So this is all nice and theoretical, and everything is beautiful, and everything's connected. So there's some real problems that you run into when you actually want to do this. So as we referred back to the first couple of slides and some of the research we did, we realized easiest way to start with is to start simple. Rather than trying to build a whole system and whole architecture and everything else, unfortunately, we are not GE, so we do not have as many people and the resources and other things. It's usually easier to stick to smaller problems and fixing smaller problems first, and then building the exercise of building the platform from there. So we looked at some basic problems. How can we provide feedback for some general things? In order to do that, we build a device. And some of you guys on the call have probably heard of this device, some of you haven't, but this, in essence, is a device called MMS Pulse. So MMS Pulse is essentially a small PC box, which is the hub, which is a central processing unit which collects the data and then streams the data to the PC for further database collection. The link is basically an amp box that allows us to stretch the sensor signal on a larger machine so that we can put more sensors on it. And then the sensors themselves, as of when this slide was put together, the four initial things we provided were vibration measurement, a crash measurement on a Z column on a CMM, a temperature measurement, and humidity. Now, a very important thing to mention here is what we started off is not determining, well, if there's this vibration, how does it affect my measurement? Because, frankly, we don't have that knowledge today. The idea is that over time, we will gather a lot of this data, and over time, we're going to build intelligence that would allow us to become predictive in what we do. So what these sensors today do, for example, temperature on a CMM, the actual temperature itself is not as critical as the rate of change of temperature. So the temperature sensor sits there, and it monitors a particular change in temperature, and if it happens, then it will alert you. And in the next slide, we're going to actually go through a small video that will show you how this actually works from the software standpoint. But on the hardware, we have added a couple of more sensors recently, which is also air pressure sensor, and then we have for vision machines, we have a luminosity sensor, which sits on a vision machine. Primarily, if you have too much light pollution or too little light pollution, you could actually affect the measurement accuracy on the vision machines. Even though they have their own filters, depending on how severe it is, there are some issues you could potentially run into. So those are sensors that try to help control, inform, and do whatever else is needed. Finally, there's a light control piece, which is only available on some of our machines today. It will be available on a full line of machines in early next year. And what it is that if you have illumination of your work surface built into your CMM, essentially when you walk away from the machine, the lights will dim. And the top piece is a proximity sensor, and the bottom piece is the intensity control. So if you actually walk up to the machine, lights are off, you can wave in front of the little sensor, and then lights will come back on. So we're trying to make a more personal kind of interaction with the machines and provide you the stuff that you really, really need. So if I go to the next slide, if we go back to the hardware, so how do you actually know what's happening in a measurement process at any time, any place, any device? So let's walk through the software, a little video, and then I'll delve a little bit deeper about this question. So I'm going to go to the next slide. I think the video is going to start automatically. And by the way, this is the simulator you guys will be able to download. So what we did is we simulated a temperature spike, and in this graph you exactly see where the temperature spike actually occurred and when it occurred. And if you stretch it out to live, to 1 hour, to a day, to a week, same goes for a crash or humidity, or if you wanted to do vibration. If you go back and you click on the top right, what you see is every single event that has occurred on your machine since the beginning of time. And then you can filter and look for particular errors that you have seen as far as it goes here. You can adjust the sensitivity of the sensors themselves. You can adjust the rate of them. And the nicest thing here is that you can actually set up an alert system. So who you are, which alerts would you actually like to see, type in your mobile number or type in your email address, and whenever something happens as an event, in those kinds, in which cases crash, temperature, and humidity, you will actually get an email or a text message. So the idea here is that if anything actually occurs on your machine, you will be able to react to it, let's go more immediately than before. So if we go back to our initial example of, so I started a machine basically crashed, even though it wasn't a severe crash, and I came back 3 hours later and just noticed that it was basically dirt inside of a feature, you would actually get an alert on your phone or in your email from MMS Pulse software telling you you have an event, you should really go back and check it out. So at this stage, what Pulse software does ultimately, and by the way, if you guys set this up on your laptops, PCs, or anything else, unless you have like very restrictive firewalls, if you actually type in your email address or your phone numbers, you can actually test it out and you'll get an SMS from the Pulse application telling you this is what happens. You can see how it actually works in the real world. If you have some issues with firewall, go ahead.
Yeah, Mel, I'm just wondering, so this application that you're talking about, is this something that runs on a server or a computer within the facility, or do you have to run this application, the MMS Pulse application, on each computer, or how is kind of what's the setup on this?
So today, that's a good question. Thank you, Dirk. Today, each one of these runs on individual CMM PC. So basically, the PC that runs software that's running the CMM would have a Pulse app running on it connected to the hardware and then measuring. We are working on enhancements to be able to view multiple pulses from either a mobile device or from a web browser. But in the version 1.0, it's all localized, so you typically have to walk up to a machine to see the real-time graph.
Okay, and obviously the SMS or the alerts that get sent out are going to tell you which machine you're getting the alert from, I'm assuming.
Correct. Correct. It gives you the machine. See, if you're in this screen, you see type, location, and part program. If you have PCDMAS, the part program name would actually be listed there. So essentially, if you get an alert, it will tell you 454SF at this location, this part program is running, this is the event that occurred, and then you can go and attend to that machine.
Okay, great. Just by the way, anybody, if you have any questions, Milan's going to continue on here, but if you have any questions, feel free to send them to us using the Q&A box in the lower right corner, or click on the green drop-down menu and click the Q&A button, and you can send questions. Thanks, Milan. Go ahead.
Okay, so the main points of what Pulse does and how does it start this journey for us towards, let's call it smart metrology, is it's a self-contained device. So we worked specifically with a goal that it works really independent of the host software. Obviously, if you use Hexagon equipment and Hexagon software, you get some additional benefits with Pulse, but if you use competitive software and equipment, that by no means does it eliminate you from using Pulse on your machines. So that way we can basically put it on anything that's out there that we need to measure those parameters that I mentioned with the sensors that are included with the version 1. It's in real time, so it provides immediate monitoring and notification. So as soon as something happens, I think we've had messages come to us as quick as 5 seconds and as slow as a couple of minutes, depending on network / cellular / other things that happen in a particular facility. Our goal is over long run is to integrate this with our internal systems, which is Internet of IoT Cloud from Salesforce, ServiceMax from Salesforce, and that would allow us to essentially collect these events and create a connectivity between you and service that's in real time. So that service, if they see there's something that drastic occurred on the machine, they will be able to contact you back. Part of the Pulse development is also to combine it with messaging from PCDMAS and to combine it with messaging from the controllers themselves. So the amount of information that's going to come from Pulse will be much larger in a sense of to give you a better idea of what's going on. The system build the system towards proactive services. We're talking here about a system called Cadence, which is one level up from Pulse that gives you a much bigger visibility. And for those of you who are on this call, some of you may be familiar that a few months back we acquired a company called QDAS that does a lot of statistical charting and statistical software, and a lot of Pulse output can actually be imported into QDAS software so that you can start matching quality statistical data with environmental conditioning. So if you're able to start assigning causes. So let's say somebody keeps opening a door on a metrology room and temperature keeps going up and down, up and down, up and down. You can start seeing that on both the Pulse display and in QDAS software, because you're going to start seeing some measurement data going out of whack possibly in a certain periods when the person has left the door open. Hence the title was to Who Left the Door Open, because we ran into this at one customer where a person would go out for a smoke break and would leave the door open on the room, and the alarm would go up, and it would shut off the machines, and a bunch of other stuff would happen. And then it would come back and go, oh no, close the door, turn on the air conditioning, life goes on from there. And it was always happening, but the people outside of the room didn't really know why something was happening. So those are the things that not necessarily to stop people from smoking. It's really there to make you more aware from what you should be doing in order to avoid any kind of issues as you're trying to gather the data. And then finally, it's of course upgradable. As we roll out new software and new capabilities in software, which are mostly tied to cloud connectivity, mobile apps, and other things like that, we will add some new sensors, we'll add some cameras, we'll add some services. You, of course, will be entitled to some of those upgrades. As we move forward, our plan is also to open up a subscription system to certain capabilities in the software. So as we move forward, there will be some basic capabilities which are available today, will be available as the price of entry as a single price of hardware and software. But if you need additional capability, especially stuff like access through cloud and mobile, those will be subscription-based systems, which will probably roll out sometime mid-next year.
Hey, Milan, if we can go back to that, slide real quick.
No problem.
And under your second item there, it says MMS Pulse can be integrated with cloud services like Salesforce and ServiceMax. Can you just real briefly tell people what Salesforce and ServiceMax are and what this integration means?
If anybody who doesn't know, Salesforce is currently, I think, the largest CRM or the customer relationship management platform software in the world. And what they provide is, CRM software for us, and we utilize their software in order to obviously talk to you customers and get the leads and figure out what we're supposed to sell you and those kinds of things. ServiceMax is an extension of Salesforce platform that allows us to basically dispatch, schedule, sell parts, and all those kinds of services. So in the background, what Salesforce allows us to do is to build more connected internal systems so that as we get information from the field, we ourselves are more informed and can react to it much more quickly. So an example of how this works is we were part of Salesforce's IoT Cloud program over the last year and a half, and what that means is we take PulseBox, we take an event out of it, it goes into something called IoT Cloud from Salesforce, and then it goes through something called a rules engine, and it's basically, if anybody's used a mobile phone, there's software called IFTT, which is if, then else. What Salesforce does is that looks at the event. So if temperature breaches 24 Celsius, then go do something. And that do something usually means create a case in ServiceMax telling service people that something has happened on the machine, and then you can choose, does that alert need somebody to react or not to react it? Well, if it's a temperature event, we typically don't react to it. But if you whacked your machine really hard against something, you probably would like us to call you and say, do you need some help or anything like that. So the idea here is, as we connect the enterprises, we become much more effective and able to provide the services back to you so we can go towards that goal of zero unplanned downtime.
Got it.
No problem. So kind of to put the wrapper around the whole talk is this question of what if there was an easy button. So the easy button can mean many different things. It's kind of using it as a metaphor for, can my machine tell me what's wrong with it? Can I just press a magic button and everything happens in front of me? So what I typically use as a good example, is the next slide, is what exactly does the future look like? Because you can see a lot of PowerPoints, and I'm sure you guys have seen, and you've watched many presentations of Industry 4.0 and Internet of Things and everything else, and everybody promises $8 gajillion of additional revenue and everything else. The thing I learned in my user experience journey is kind of, these are the two pictures from, I think, roughly early 1950s. So we have robot warehouses, which exist today, and push-button education, which I guess kind of exists today. But if you look at how they look in the images and what they look like, people can only imagine things usually within the confines of what exists today. So how do we imagine the future is what we know exists today without really knowing what will exist tomorrow. But what we can see is based on research, based on desire of enterprises to actually connect everything, based on the desire to put in some artificial intelligence into the machines themselves so that you don't have to literally sit next to them to observe what they do while they're doing it, and to put in an interface to all these machines that is as simple and as similar as your smartphones, or as what I've reasoned Facebook, which is one of those interesting lessons is if you want people to be able to use your software, make it look like Facebook because people use it every day. But the interesting exercise here is that the things we are actually looking into is starting to build a more of an ecosystem around your machine. So if I take Pulse, it starts monitoring environment and controller and what software does and informing you if something goes wrong, or it can inform you if something goes right. That's not necessarily out of the question. But then putting cameras on CMMs to be able to monitor what you do so they can tell you how something occurred so you can rewind the time and essentially find why something went bad. Or even better, when you have a part, you put a part on and you press the magic easy button and the machine knows what part it is, what program it has to recall, and what it has to run, and who it has to inform when this whole thing is done. And then you guys have seen stuff like virtual reality and augmented reality, and idea if you forward in the future is that do we really need to keep printer ink and spools of paper in our back rooms, which a lot of you guys probably have, is the results can just be projected on top of parts, and when everybody downstream looks at it, you can just overlay it on top of what they see. So as you look at what exactly is the future metrology, what we're leaning towards is future metrology. We all know that non-contact sensors and those kinds of things are influencing how we gather the data. The data is not reducing. There's more and more data being gathered. But the machines themselves, CMMs as a frame, are not going to get much more accurate or not going to get much faster. So the future in our world is more towards usability, connectivity, being able to extract meaningful data out of all your measurements to be able to essentially improve your production so that when you make the parts, you make less bad parts and a lot of really, really good parts, which ultimately gives you the goal of shipping stuff on time and not stopping the production and being as effective as you can. So if I kind of look at what we look at and what we think are the key takeaways that we would like you kind of to think about as you move forward, which is everywhere we talk to and everywhere we do research, we see that there's more and more desire to connect machines and view important data on any device, any place, at any time. That means ultimately that as your machines either measure or they have something happen to them, rather than having to physically be there and physically drive back at 2 a.m. because something happened on the third shift, you were able to view and possibly affect what happens remotely because you're fully informed why something actually happened. As we view the world in that kind of sense, we think Pulse is a good first step for us toward Industry 4.0, with obviously some more exciting products in the pipeline to fill the kind of the ecosystem we're trying to build. But why Pulse seems to have kind of hit the good nerve with some of the key accounts we have talked to is because it addresses some of the simplest issues right off the bat. And as we're deploying it now on quite a few sites in the last 2 months, we obviously have a deluge of enhancements that people are asking for because they would like to be able to do, for example, one of the customers asked, when the event happens, I would like the message to pop up and give me a list of assignable causes so I can assign a cause to what something happened, so that in the future I can say, well, what's my #1 assignable cause? Somebody driving a forklift next to a machine every 5 minutes or something along those lines. So as we develop and as we learn more and as we gather more data, our hope is that we will get more intelligent and help you guys be ultimately more productive and be able to operate at the best efficiency that you can. Finally, as we gather this data and as we give eyes to machines and as we give a little bit of a brain to the machines, ultimately building this kind of artificial intelligence of the machines will help you make these repetitive tasks much more efficient. So when you start combining Pulse with QDAS with your measurement software, if you start noticing that a particular characteristic that you have is within limits of the last 20 part that you measured, you can suggest that you stop measuring that particular characteristic and then move on. And if you notice again that something has gone bad, you can then suggest again to adjust the process on its own. So a lot of things that you guys do today manually, our idea is to take over and help you so that you can focus on more important things than necessarily having to hover over the machine and see what's going on or waste your time trying to seek a cause of something that's been driving you mad, and it turns out, as we said, it's as simple as somebody leaving the door open. So with that, I'll finish up and we'll leave it to Dirk. And if you guys have any questions, I will gladly answer them.
Yeah, thanks, Milan. So we're going to get to our questions now. By the way, if you have any questions, send them to us using the Q&A box. You can see that in probably the lower right corner of your screen or the green pull-down menu on the top of your screen. So one of the questions that came in is, are you currently using MMS Pulse with any of your clients, and if so, how long?
We have installed it. It's been on a beta site since last year. The first commercial installations started probably about 4 months ago, and we just recently, about a month and a half ago, received a rather large, sizable order, about 105 units for one of the key accounts of Hexagon's. And that installation obviously is going on and it's being put into production. And we have probably about 4 other large key accounts looking at deploying Pulse in the very near future. So it took a little while to get into production and to get awareness of Pulse. And primarily, I think, Dirk, the good thing to mention here is that our own sales force is used to selling capital equipment, and this is something that's slightly different. So we had to go through a good internal education to get people aware exactly what does Pulse do and what can you do for the customer.
Is there an API or a gateway that would allow your customers to get data from MMS Pulse for custom reporting?
That is in development right now. It is with our group in Switzerland, and we're using something called an Edge client, which is an internal tool for middleware It will essentially allow you to subscribe to particular data coming out of Pulse, and in the long run, it will allow you to subscribe to any data coming out of any of the devices in the Hexagon family, but that's probably further down the road. The edge client integration with Pulse is about to be finished, and I will actually be traveling to Switzerland next week to find out the state of edge client of being released as an API product to the customers. Right now, what we can do is it's a Pulse saves data in a SQL database, and we will easily give you access to that database, and you guys can actually take data out of it if you need to. So we have a couple of ways of getting around it, but we would like to provide a much better, more robust way in the future.
Okay. As an IT manager, I am concerned about collecting sensitive data. What is your position? I think this all gets back to kind of the cloud security, all that stuff around cloud and IoT and so forth.
Correct. The interesting journey that we have had is that every enterprise is slightly different. One of the accounts we talked to essentially connect any machine to the cloud, we don't care. Other much more protective enterprises are like, well, as long as my measurement software is not connected to the internet, I'm okay with that, which is ultimately what we're developing with version 2 of Pulse, is that independent device on its own that can be connected up to the cloud, meaning that it doesn't connect to the host PC, it just connects to the machine. So the operations of machine would be secured in the cloud, and we're working with Azure and Amazon Web Services who have their own built-in security in order to protect and compartmentalize the data by the customer. To say that we have a solution today would be slightly premature, but every key account we have ever talked to, number one concern is obviously security, especially if it contains any measurement data. The concern on utilization and kind of the event stuff that we talked about for Pulse is slightly less so, but not without concern in general. And especially if we talk about adding cameras, most accounts are basically saying if you film things, the video has to be stored in a local cloud and not in a public cloud for obvious reasons. So as we start connecting things, we are working with every possible version of what is allowable and what is not allowable, and we will, over the next 6 months to a year, we will provide a much more in-depth solutions for that kind of stuff.
Okay. Do you envision Hexagon taking part in such initiatives as MT Connect?
I have a good answer to that, kind of, I guess a good answer. But one of the key accounts that we work with and who is interested in Pulse, obviously, is GE, which the majority of internal communication for the data protocols is through MT Connect. And as part of that, they have asked us to develop data outputs from Pulse that are compatible with MT Connect. So it's part of our roadmap. I can't necessarily give you when it will be out, but it is definitely in the forefront. And we would like to get, obviously, over time, get more involved with MT Connect, just because it seems that not only GE, but many, many other places are utilizing it. But we ourselves have to kind of answer some more internal questions first. But in the long run, the answer is MT Connect is definitely of interest in what we're trying to do.
Okay. Now, in one of your earlier slides, Milan, you talked about, all this data that we're collecting, and we only, utilize or look at, 1% of it, and that's probably because we're inundated with data. So, if somebody's interested in using this type of system, MMS Pulse or whatever, the question to me comes up is like, okay, so what data am I going to collect? What should I be looking at?
Well, there's two houses of belief, I guess, in this particular domain. One house believes what you do is you collect everything, and then using analytics, you figure out exactly what's important. I'm not necessarily in that camp because I think you need a lot of time to figure out what exactly is important. I'm more of a camp that we start little, meaning we pick 10, 15 different things that we know can give us certain information about operations of machines, and we focus on those, and then we add a little more, and then we add a little more, because ultimately, even though we only really utilize 1% of the data, as everybody knows, with spam emails and all the Candy Crush invitations on Facebook, majority of data that we gather is actually garbage. So if you start sucking garbage into a system, what you're going to get out is garbage. So my personal approach is to be more cautious on what data you start working with and what you actually gather, because the other data will always be there, so we can always add more things. If you start with a deluge, you potentially end up with just nothing. So.
Okay. You know, it occurs to me that what with more and more metrology equipment, CMMs, you know, and so forth, being now handled by robots. So, you know, the robot is handling the CMM, or the robot is, you know, placing parts on a CMM, so you can have unattended, measurement of, you know, parts all night long. That's kind of what's driving a need for this. There's probably more unattended CMM or measurement operations going on now than there were, you know, what, 10 years ago. I mean, would that seem like a good assessment?
Sure. I mean, there's a boom in automation, as everybody knows, in all aspects of manufacturing. You know, welding robots are old news, but all the other stuff seems to be, kind of progressing into other aspects. I think manufacturing robots were always there, and always automation was always there. There's more and more movement of inspection equipment into the production lines. So in the old days, when I started, which was, what, mid-90s or something, there was a lot of people in lab coats in air conditioning rooms, and they were very popular with other people in the factory, especially in the summer. And you saw a bunch of carts with parts lined up, and they were waiting to be inspected. In today's world, all those CMMs are slowly migrating closer and closer to production lines, which means they have to be integrated much more into what they're starting to do, meaning that, as you said, they're running more and more unattended, the same as those robots do. So if something goes wrong, you have to be much more aware and much quicker to react, because if you don't, in the old days, okay, so some of the parts stack up in front of the inspection room. Today, you can shut down the production line if something happens with a CMM. So the exposure and the risk to production is much, much higher. So you have to be more informed. You have to be able to react faster and do those kinds of things. And I can see that happening more and more, and not less and less.
Okay. So, you know, you mentioned earlier that this is basically this kind of runs standalone at the moment. So in the future, is this something that where this is going to be, you know, the MMS Pulse on multiple machines in the facility are going to be connected to, let's say, Hexagon? So as a service, Hexagon will monitor your machines and do the predictive maintenance for you, and so on and so forth?
That behind the scenes, that's the idea. And at IMTS this year, we showed first version of Cadence, MMS Cadence. So in kind of the scenario you put up, if we have a customer with 100 machines with Pulse on it, if you have MMS Cadence, then you can view all those pulses within one view window and see everything that happens in your factory. The nice thing about Cadence, it's not only that. It also shows you the utilization of your machines. It shows you the reports of every part that was ran on every single CMM, and then some statistical analysis from QDAS, and it's all tied to an essentially, let's call it either enterprise-wide or a factory-wide dashboard. The idea is that we then connect it, again, as we talked earlier, to the cloud and back to Hexagon, so that with the agreement of the company itself, if we have the visibility, we can then essentially go towards some of the software as a service things, but also move towards essentially offering a much more proactive service offering, so that we can see when machine is due for preventive maintenance or a machine is due for calibration. So machine can also, if we're smart enough, we can have machines start scheduling themselves without people actually having to do anything. So the dream, you know, to move a few years forward is exactly that, which is ability to connect all these things, to be able to provide you live data about which routine from which software is running on which machine, which machines are overutilized, which machines are underutilized, make some suggestions how you should shift your measurement around, and then tell you if what's going on the machines themselves, if they're breaking down, not breaking down, if people are smashing them or having issues with temperature and those kinds of things. But the bottom line is to build this more informative enterprise, and then you can view from any place, anytime, on any device. Okay.
Well, Milan, thanks for really for a great description of well, really how the Internet of Things and Industry 4.0 are going to be influencing really how manufacturing works in the future. Thanks for a great presentation.
Thank you, Dirk, for having me. Looking forward to some other time, some other wisdom that I can spew out.
You're full of wisdom, Milan, I know. Thanks to all of you as well for joining us. You will be receiving an email with a link to a recording of this webinar as well as a PDF of the slides. And you're also going to be able to download and run a simulation of the MMS Pulse screen that Milan was showing you there earlier, so you can run it on your computer, kind of play around with it, get an idea of what that solution looks like. So keep your eyes open for that email. It should be coming out tomorrow. So once again, from all of us here at Quality Digest and Hexagon Manufacturing Intelligence, have a great day, and we will see you at the next webinar. So long.